Okay, so problem number 6 says listed below are 5 functions, each denoted by g of x. If each of these, for each, or and each involving a real number constant c, where c is greater than 1, and f of x is equal to 2 times x. So the question is, which of these 5 functions yields the greatest value for f of g of x and I'm just going to write that down real quick, the composite function. So it's really, and basically what I did is wherever there was an x in the original function, I replaced with g of x. Alright, so which one would yield the greatest value for f of g of x if I let x be greater than 1? Alright, so let's write down what these functions are. So if I plug in the first term a, f of g of x would be 2 raised to the g of x, which is cx. B would be f of g of x, which would be 2 raised to the c over x. C, which is f of g of x, will be 2 raised to the x over c. D would be f of g of x, and g of x was x minus c. And so all these terms, I've got g of x here, and I'm just plugging in my g of x's 2 raised to whatever g of x is. Okay, so that's where I'm getting those from, and here's all my g of x's listed here. Let me zoom in a little bit so you guys can see them a little better. Alright, so now my next one is E, f of g of x is equal to 2 raised to the log of c of x. Okay? Log base c of x. So now I just got to figure out which one's greater. Well, the product c of x is going to be greater than the quotient of c over x, and it'll be greater than the quotient of x over c, because both c and x are greater than 1, and so when you multiply two positive numbers that are greater than 1, it's always going to be greater than the quotient, right? 2 times 2 is 4, so 2 raised to the 4th. But 2 raised to the 2 over 2 would be 2 to the 1st, and so on and so forth, no matter what numbers I plug in. Well, the difference of two numbers is always going to be less than the product of two numbers. So now we've got 2 here that we need to check to see. Well, I'm going to use my properties of logs to rewrite this equation as 2 of the natural log of x over the natural log of c. Now the reason I'm doing that, I'm going to plug it in my calculator. And I kind of cheated. I thought about this problem before I recorded it, and I entered in some information. So what I did is I used a simple value of letting x and c be the same number, because it didn't say they couldn't be the same number, but I wanted to see if there was a pattern here. So I put in negative, or I put in for x 1.1, right? So if I take the natural log of 1.1 and then c is 1.1, and over the natural log of 1.1 I get 1, right? And then if I take 1.1 squared, I get 1.2. So this would be 1.1 times 1.1 squared, which would be larger than this value. In other words, what we're really trying to determine is which is larger. Is c times x larger, or is the natural log of x over the natural log of c larger? Well, in this case, I think the product of cx will always be larger. Let's do it one more time though. So if I say natural log, and we'll let x equal 2, divided by the natural log of x equals 3, or c equals 3, I'm sorry, I get this crazy decimal. But if I say 2 times 3, I get 6. So since this is an all or nothing type of deal, I've just plugged in 2 values for c and x, and I got a larger value for A than I did for option E. So my final answer would be A. Actually, there is a better reason for this. This is a product of two numbers, sort of like the natural log of a number. And so the ratio of the quotient would be similar, and it would always be less than the product of c times x. So this is greater, which is option A. So of those two, if I let option A, with g of x is equal to cx, that would be the better answer.